In the previous video, we saw that the encoding of the string math is 172,084. So with that in mind, we know that the decoding of 172,084 is going to be the string math. But I think it's good for you to see what the answer is before we decode it so you can see these letters popping up. Now remember how we, in the previous video, found this encoding of the string math, or math. We took M, A, T, H, we assigned a number to them. This was the number 13. This is the number 1. You can see that right there. T was assigned 20. H was assigned 8. And so that means that this is 13. This is 1. This is 20. And this is 8. So now we'll see how we can find those numbers. All right, so because we used this number here as our way to encode math, we'll now set 172,084 equal to this n0 plus n1 times 27 plus n2 times 27 squared plus n3 times 27 cubed. And first we'll solve for n0. The way we're going to do that is we're going to mod out by 27. So we're going to look at this equation mod 27. And notice that mod 27, n1 times 27, goes away. That becomes 0. This is because 27 is congruent to 0 mod 27. Similarly, 27 squared is congruent to 0 squared, or 0 mod 27, so that'll go away. And for similar reasons, that'll go away. All right, so now looking at 172,084 mod 27, we get the number 13. Now this is because when you divide 172,084 by 27, the remainder is 13. So we get 13 is congruent to n0 mod 27. Now because n0 is a number between 1 and 26, right? But this is because it's a number that corresponds to one of the numbers between 1 and 26, 1 corresponding to A and 26 corresponding to Z. It's one of those numbers that corresponds to the letter in the alphabet. Because n0 is a number between 1 and 26, we can immediately conclude that n0 has to be 13. Not only is n0 congruent to 13 mod 27, but because of this, we know n0 has to be 13. And let me show you why. All right, so remember what 13 congruent to n0 mod 27 means. This means that 27 divides n0 minus 13. Now remember what that means. That means that there's some integer k such that 27 times k is equal to n0 minus 13. And so now adding 13 to both sides, we see that 27 times k plus 13 equals n0. So now what this is going to show us is that k has to be 0. Now why is that? All right, so let's see. Let's think about what would happen if k was negative. All right, best case scenario, k is -1. If k is -1, then 27 times -1 is -27. -27 plus 13 is a negative number. But remember, n0 has to be between 1 and 26 inclusive. So that means k cannot be negative. If k is -2, then it's even worse. It's -2 times 27. It's even bigger in absolute value than 27 times -1. Now, what would happen if k was positive? If k was, say, 1, then we'd have 27 plus 13 is n0. Well, that's bigger than a number in this range. So that means k cannot be positive. So k cannot be negative, k cannot be positive. So there's only one other integer that k could possibly be. It's got to be 0. All right, so because n0 is a number between 1 and 26 inclusive, we must conclude that n0 equals 13. And so now we can put 13 in here. All right, now repeating the process. So first we're going to subtract 13 from both sides. So 172,084 minus 13 is 172,071. And so now we have this equation. And we're going to solve this equation now for n1. So what we want to do is we want to make both of these go to 0 by modding out by 27 squared. Okay, so if we look at this equation, mod 27 squared, then this becomes 0. This becomes 0, and this becomes 0. This becomes 0 because 27 squared is congruent to 0 mod 27. And this becomes 0 because 27 cubed is congruent to 27 squared times 27, which is congruent to 0 times 27, or 0 mod 27 squared. So now looking at this equation, mod 27 squared, on the right-hand side, we just get n1 times 27 mod 27 squared. And dividing 172,071 by 27 squared, we get the remainder 27. Now dividing both sides of this equation by 27, we get that 1 is congruent to n1 mod 27 squared. And for similar reasons as to with n0, since n1 is between 1 and 26, this tells us that not only is n1 congruent to 1 mod 27 squared, but that n1 actually equals 1. All right, and so now we can put n1 in here, n1 equals 1 in there, and subtract 1 times 27, or 27, from both sides to get 172,044. And now we'll repeat the process. So now we want this to go away. So to make that go away and this not go away, we're going to look at this equation, mod 27 cubed. This becomes 0 or goes away because 27 cubed is congruent to 0 mod 27 cubed. And 172,044 divided by 27 cubed has a remainder of 14,580. So 14,580 is congruent to n2 times 27 squared mod 27 cubed. Now dividing both sides by 27 squared, we get that 20 is congruent to n2 mod 27 cubed. And similarly, since n2 is between 1 and 26, this tells us that n2 is not only congruent to 20 mod 27 cubed, but that n2 is equal to 20. All right, so now we can put n2 equals 20 in here. And now we don't need to do any more modding. Now to find n3, we see that, remember this is multiplication there, we see that n3 is going to be 172,044 minus 20 times 27 squared divided by 27 cubed. And that's how you solve those.